Hello, this is Ryan from High Desert Math Tutor, and today I want to talk to you about horizontal asymptotes. So I've talked to you about vertical asymptotes and holes in other videos, and in the future I will be making more videos where I talk about slant asymptotes, but today we're talking all about horizontal asymptotes. So this should be a quick video, and to begin, we need to notice that there are actually three different outcomes that we can have when we're talking about horizontal asymptotes. So some terms you need to be familiar with. What you must be familiar with. You must know leading coefficients. You must know the degree of a polynomial. And you must be familiar with the word ratio, which is just fraction. Okay, so leading coefficient. If you have a polynomial, such as this numerator right here, in standard form, the leading coefficient is literally the first number you see in front of x. But as a more general definition of a leading coefficient, you pick the highest power on x, whichever term you have here, and the number in front of that x is your leading coefficient. So here we have the highest power on x as a 6. That means the number in front of this is a 7. That's our leading coefficient. For the denominator, we see here that there's just x to the 15th. So the number in front of this, since we don't see it, it's actually a 1. The leading coefficient for the denominator would be 1. One final example, we have x to the 5th, 2x to power 1, then just a 3. So the highest power on x is 5, and the number in front of x is -1. So -1 would be the leading coefficient here. So there are three possibilities when we talk about horizontal asymptotes. Now, when you have a degree of your numerator that is greater than the degree of your denominator. Now, stepping back just a moment, degree of a polynomial is the highest power on x. So here we're going to be focusing on the numerator separately from the denominator. And we want to focus on the degree of the numerator and compare that to the degree of the denominator. So if you have a degree of a numerator that's larger than the degree of the denominator, that means you have no horizontal asymptote. Another situation is where the degree of the numerator is the same as the degree of the denominator. In this case, you have a horizontal asymptote, which is a y value, and that y value is the ratio or a fraction put together with the leading coefficient of the numerator divided by the leading coefficient of your denominator. So the degree of the numerator could be greater than the degree of the denominator. The degree of the numerator can be equal to the degree of the denominator. Finally, the degree of the numerator can be less than the degree of the denominator. And this is actually a very easy situation because in every situation here, the horizontal asymptote is always the equation y equals 0. So this is certainly a very easy situation to manage for having a horizontal asymptote. If you don't have a horizontal asymptote, this is very easy to see. And when you do have a horizontal asymptote that is something other than 0, it's not much work to put this ratio together. So let's just look at these three quick examples to actually come up with the horizontal asymptote. So step 1, we need to look at the degree of the numerator and the degree of the denominators. So we see for this first example A, the degree of the numerator, the highest power on x is 2. the degree of the denominator, the highest power on x down here, is also 2. So in this instance, for this example, the degree of the numerator is the same as the degree of the denominator. So that tells us our horizontal asymptote is going to be the equation y equals. Now we need to take the leading coefficient of the numerator. So the number in front of the highest power of x, the term with the highest power on x, the coefficient is 3. The number or the coefficient in front of the term with the highest power on x in the denominator is a 5. So the equation for the horizontal asymptote is y equals 3 over 5. That's it for this first example. For the second example, we need to look at the degree of the numerator, which we see that the degree of the numerator is 6. We look at the degree of the denominator, which is 15. And we see here, for this example, the degree of the numerator being 6 is smaller than the degree of the denominator. So when we compare this information to our table with all the possible outcomes, we see that our horizontal asymptote is simply the equation y equals 0. Now for our final example here, we see, as always, we need to compare the degree of the numerator to the degree of the denominator. So the degree of the numerator here is 5. The degree of the denominator here is 2. So that means for this final example, the degree of the numerator is actually greater than the degree of the denominator. If we go back to our table here, we see when the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So to rephrase that, for the horizontal asymptote, there's no horizontal asymptote. So it's as easy as that. Whenever you have a rational function, which is a fraction built with polynomials, all you have to be familiar with to identify the horizontal asymptote. Be familiar with what a ratio is. It's simply a fraction. You have to be familiar with the degree of a polynomial. So look on top, and what's the degree of this polynomial? Look on the bottom, ask yourself what's the degree of this polynomial? And finally, you have to be familiar with the idea of a leading coefficient so that you can actually take the coefficients for the leading terms, and whenever appropriate, you put these together to come up with the equation for your horizontal asymptote. So as a final note, just be aware that your answer for horizontal asymptote should always be an equation. So horizontal asymptotes are always stated or given for your final answer. They are always stated as equations such as y equals 0, or I'll take that comma away, y equals 0 or y equals, say, 3 over 5. So the equation always has a y value if we're talking about normal x-y axes or the Cartesian plane. So that's it. Just be aware. You have to be familiar with this table. So if needed, feel free to come back to the video. Just skip to the end and look at this table anytime you need to review horizontal asymptotes.